Hello, fellow ASB members. I'd like to welcome you to my home today in Evanston, Illinois, where I'd like to speak to you for the next 5 minutes about my work on obesity and falls in older adults. And I'd like to just acknowledge that Michael Madigan is also an author on this work. As everyone listening is well aware, falls by older adults represents a significant problem, with about 1 in 3 older adults falling annually. What people may not be aware of is that obesity in older adults increases the risk of falling by up to 50%, depending on the level of obesity. And our work suggests that obesity may be particularly problematic in that it increases the risk of trip-related falls, which is what we wanted to understand further. So we looked at some of the literature, and some early work suggests that obesity may actually be protective against falls that involve little or no initial angular velocity. However, if an initial angular velocity is present, obesity may actually impair recovery responses. And this would be the case, for example, when experiencing a trip during gait. So this basic concept informs our hypothesis, which is stated here in words, but also shown is schematically below. In essence, we hypothesize that there would be an interaction between obese and normal weight groups in terms of how trunk kinematics, both trunk angle and trunk angular velocity, scaled as a function of perturbation strength, which here we define in terms of acceleration of a treadmill. So how did we test this hypothesis? We recruited 29 normal weight older adults and 30 obese older adults. All participants were screened and I say were otherwise healthy in that normal range of motion, no joint replacements, and all participants self-reported the ability to walk for a mile at any pace without having to stop. Participants completed functional tests and then returned to the laboratory for a second session where they completed perturbation testing. The perturbation testing involved participants standing on a motorized treadmill that would suddenly accelerate underneath them. The treadmill would accelerate at anywhere between 1.5 and 3.5 meters per second squared. There were a total of 10 accelerations, which were each experienced 3 times for a total of 30 trials. During all trials, participants wore a safety harness, and we recorded their motion or body motions using motion capture. And the motion capture data was then entered into mixed model analysis to test for the interaction effects. And in addition, the mixed model analysis allowed us to include a term for random effect of subject, which was interesting to us because we wanted to be able to identify whether the extent to which kinematics scaled with acceleration was related to functional ability. So what did we find? Well, first of all, looking back here, we focus on our hypothesis. For each of the 4 variables, group by acceleration was significantly different as expected. When we look at the individual subject effects, which you can see on the figures at the right, we can better understand this. For example, on the right here, we see the trunk kinematics, the trunk angular velocity on the first step plotted as a function of the acceleration. Each curve in color represents the model fit for a particular subject. And you can see that the slopes for the obese are generally steeper than for the normal weight, and even though the obese tend to start at a lower intercept. And so what we did is for those 3 variables, you see the last 3 variables where subject term was significant, when we correlated that with our functional measures, we saw moderate correlations existed among many of the variables, which we suggest indicates there are certain capabilities involved in recovering balance and controlling the trunk that are also necessary for these functional tasks, which is relevant in that it suggests that a battery of these functional tests could serve as a metric of an individual's response capabilities in absence of being able to directly measure that. More importantly, we confirm that obesity provides protection against falls at low velocities but not high velocities, which provides impetus to utilize high velocity perturbations to train important recovery responses to prevent falls within obese older adults. I'd like to thank everyone for listening and wish you all a great day.